Good morning, sir. Good morning, classmates. Welcome to our class in Advanced Plane and Solid Geometry. I am Isabel H. Fernandez, your presenter for today, and we will be discussing about regular polygons and circles. I hope we will learn something great today. Let's start. First, let us define the literal meaning of a regular polygon. A regular polygon is a polygon that is equiangular and equilateral. We can say that a polygon is regular if all of its angles and sides are congruent. Equiangular means the same measurement of angles, and equilateral means the same length of sides. I know all of us are familiar with common types of polygons. We have triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. Now, let us talk about the parameters involving regular polygons. The side, angles which are exterior and interior, perimeter, and area. Let us discuss this one at a time. Side. Polygons and its number of sides. These first 8 polygons are already discussed. So we will move on the polygon that has 11 sides, which is the hendecagon or andecagon. 11 side. Next one is the decagon that has 12 sides. Triskaidekagon, 13 sides, and so on. Here we have icosagon that has 20 sides. Pentacontagon, 50. Hectagon, 100. Myriagon, 10,000. And Googlegon, for 10 raised to the 100 sides. The second parameter is the angle. It has two different types, the exterior angle and interior angle. An interior angle is any angle that is on the inside part of a polygon. And the exterior angle is any angle that is on outside. Exterior angle has a formula of 360 degrees divided by n, where n is the number of sides of the polygon. That's why it is important to remember the number of sides of regular polygon because we will use that in most of our formula today. For interior angle, the formula is quantity n minus 2 times 180 degrees divided by n. Later, we will apply the two formulas on our example. The third parameter of a regular polygon is the perimeter. Perimeter is the sum of the lengths of all the sides of a polygon. Let's say we have a regular triangle whose length of one side is 10 centimeters. From this illustration, we can know that the perimeter of this triangle is 30 centimeters, or just simply multiply the number of sides of the given polygon to the length of its side. P is equal to S times N, where S is the length of the side of the polygon and n is the number of sides. For the last parameter, we have the area. The area of a polygon measures the size of the region enclosed by the polygon. We can solve it by using this formula. Area is equal to 1/4 ns squared cotangent pi over n, where n, of course, is the number of sides of a polygon, s is the length of one side, and 3.1416 for the value of pi. Let us now use the given formulas in our examples. Example number 1. Find the perimeter, area, exterior and interior angles of a regular pentagon whose side is 7 centimeters. Let us now show our solution. We have S for the length of the side of the pentagon, which is 7 centimeters. N, which is the number of sides of a pentagon, equals 5. We have the formula for perimeter, that is P is equal to S times N. We will substitute the given. S is equal to 7 centimeters and N is 5. We will just multiply 7 centimeters and 5, and we will get 35 centimeters for the length of the perimeter of our pentagon. Next is for the area. We have the formula 1/4 times n s squared cotangent pi over n. Let us substitute the given. Area is equal to 1/4 times 5, which is the number of side of a pentagon, times 7 centimeters squared. Cotangent times pi is 3.1416 divided by 5. Let us multiply 1/4 and 5, so we will get 1.25 times 7 squared is 49 centimeters squared. Cotangent, let us divide 3.1416 and 5. We will get 0.63. Area is equal to, let us multiply this 2. So we have 61.25 centimeters squared. Let us compute the cotangent of 63. And that is 32.21. And let us multiply these two numbers. We will get the area of 1,968 centimeters squared. Now let us compute the angle of exterior. So we have 360 degrees divided by n for its formula, and 360 degrees divided by n is equal to 5. So we will just divide 360 and 5. So we will have 72 degrees for our exterior angle. Next, for interior angle, we have the formula equals n minus 2 times 180 degrees divided by n, where n is equal to 5. So let's substitute. Interior angle is equal to 5 minus 2 times 180 degrees divided by 5. 5 minus 2 is equal to 3. And 180 degrees divided by 5 is equal to 36 degrees. We will just multiply 3 and 36, and we will have 108 degrees. And if we add the exterior and interior angle, we must have the total of 180 degrees. And that's all for the regular polygon. Our next topic is the circle. Circle derives from the Greek word krikos, meaning hoop or ring. Circle is the set of all points in the plane that are fixed distance, the radius, from a fixed point, the center. Circle is a simple closed curve that divides the plane into two regions, an interior and an exterior. We have 6 parameters involving circles: the origin, circumference, lines like radius, chord, diameter, secant, tangent, and arc, angles, which are reflex and non-reflex, slices, sector and segment, and the area. First is the origin. It is the center of the circle, the point equidistant from all points on the circle. This is the origin, the center of the circle. Origin. Next is circumference, which is the distance once around the circle. Circumference. This is the circumference. Its formula is C is equal to 2 pi r, where r is the length of the radius and pi is 3.1416. Third is the lines. That composes of 6 sub-parameters that are radius, chord, diameter, secant, tangent, arc, which is major and minor. Radius is any interval joining a point on a circle to the center. So we have 2 points, any point from circle and the center. Next is chord, an interval joining 2 points on the circle. 2 points on the circle. This is the chord. Diameter, a chord that passes through the center. Since a diameter consists of 2 radii joining at their endpoints, every diameter has length equal to twice the radius. This is the diameter. Secant, a line cuts a circle at 2 distinct points. Cut the circle. Tangent, a line that just touches the circle as it passes by. This is the tangent and we have the point of tangency. Arc, we have major and minor arc, a part of a circumference. So the yellow part is the minor arc and the red one is the major arc. Fourth parameter is angles. We have reflex angle, which is angle subtended by the major arc. The non-reflex angle is angle subtended by the minor arc. So this is the non-reflex angle, the yellow one, and the red one is the reflex angle. Next is slices. We have sector, which is major and minor, quadrant and semicircle, and segment, which is major and minor. Sector, a region bounded by two radii of equal length with a common center. So this is a minor sector. Piece slice. And the red one is the major sector. We have also quadrant, quarter of a circle, and semicircles, half a circle. So this is the quadrant, and this one is the semicircle. The other example of slices is the segment, major and minor. Slice made by a chord, a region bounded by a chord, and one of the arcs connecting the chord's endpoint. The length of the chord imposes a lower boundary on the diameter of possible arcs. So this is the minor segment, the yellow, and the red is the major segment. And the last parameter of the circle is the area. The area of a circle measures the size of the region enclosed by itself. We can solve the area of a circle by using this formula. A is equal to pi r squared. Let us now use the given formulas in our example. A circle has a radius of 3 centimeters. Find the following: A, area, B, diameter, and C, circumference. Let us now show our solution. The given radius is equal to 3 centimeters. Let us compute for the area of a circle using this formula. A is equal to pi r squared, where pi is equal to 3.1416 and r is equal to 3 centimeters. Before we multiply these two numbers, make sure that we get the squared of 3 centimeters first. So 3 centimeters squared is equal to 9 centimeters squared. And this will be multiplied to 3.1416 so that we will have the area of 28.27 centimeters squared. Next, let us solve the value of the diameter, which is 2r. So obviously, our diameter will be 6 centimeters. Diameter is twice the length of radius. Lastly, we have circumference equals 2 pi r. 2 times 3.1416 times 3 centimeters. So we will just multiply these three numbers so that we will have 18.85 centimeters for the length of the circumference of the circle. Thank you so much, classmates, for watching and listening. God bless you.